Kubernetes, just like Sandeep mentioned, it's a tool where you can host the containers, right? But one thing is that there is something which is open source, right? When we saw open source, just give a moment, everyone. Okay. So Kubernetes is something which is a open source offering, which means anyone who wants to utilize this offering on on-prem cloud anywhere, you can leverage it, right? You can run it onto your servers as well. There is no problem in doing that, right? So Kubernetes is an open source offering or open source container, right? Open source container orchestration software, right? Because we always talk about Kubernetes as an orchestration. So container orchestration. This word is important, right? Orchestration software. And orchestra comes from a place where you have the services running, and those services are running collaboratively together, right? You combine a lot of components and then they work. So it is a service which is acting as an orchestration for your containers, right, everyone? So who evolved Kubernetes? Who actually built Kubernetes? Google. Google, right? So it was developed by Google. But usually what we say, it is originally developed by Google. Just like you have a stock Android. Android was developed by Google, right? But later on, everyone customized according to their usage. Correct? Is that right or wrong?
Yes, sir.
Correct? Everyone is using Android, but initially it was developed by Google only, right? Also, the first release which happened, I think it was around 21st July, right? Around 2015, it was launched, right? So the first release was on July 21st. It was done on 2015, correct? And it is considered as one of the most active GitHub repository in number of commits, right? And let's say if we talk about top 10 GitHub repositories, right? So this comes on number 9th, right? Comes on number 9th, means obviously this ranking may have changed, but earlier when I learned through the documentation, at that time they considered that, okay, this comes at the 9th most active repository. Let me just write that, but you can check the latest figures. There's the 9th most active repository on GitHub in terms of number of commits, right? The number of changes or customization which was done, that was happening on the Kubernetes level, because everyone or the people who were there as a part of the community, everyone wanted to work on Kubernetes, right? Correct? And there were n number of features. So what is the icon of Kubernetes? You will always see there is an icon of Kubernetes, right? Let me show you Kubernetes. So this icon which you see, this icon is of Kubernetes. So wherever you see this is the icon. It is referred to as a Kubernetes icon, right? So every product, Docker has a image of a whale. On top of that, there are a lot of containers. It's like they are on the ship, right? So that is the icon of your Docker. Similarly, this is an icon of Kubernetes. Now, when we were talking about Kubernetes, there is one thing which I mentioned about pods, right? And I think everyone at that time said that you have never heard about pods. So the features of the Kubernetes is a lot of features which you get in Kubernetes. Let's say features and functionality, correct? So the features which you get is, let's say, whenever you are working on some kind of service discoveries, or you're acting where you want to replicate the jobs with the help of a manager. So it is acting as a, or you act as a, first is your replication controller. Because there is a controller who is managing everything, right? You can also do resource monitoring inside this. You can have resource monitoring, correct? If you are planning to do storage management, that is also taken care by Kubernetes. Correct? If you talk about service discovery, that you also get, right? Networking responsibility, that is also taken care by Kubernetes cluster, right? Sandeep mentioned about secret management, right? Secret management is also possible in Kubernetes. In case if you are implementing any kind of rolling updates, right? So those rolling updates are also available in Kubernetes, right? What else? Replication, resource monitoring. Yes, you can also achieve health checks. Health checks you can also get, right? And there was a concept of pods, which was also introduced. And this pods is nothing but these are your containers. Pods as in this is the one where you are managing the pods, right? Container management, I would say. Correct? So lot of benefits, lot of features were there, right? Which you are using. Now let's say when you're using your capabilities, you have two major functionality, right? Just like it was highlighted by Anush as well, that there was Docker Swarm was also there, and we have Kubernetes. Kubernetes is a new functionality, right? So you have Docker Swarm, correct? And you have your Kubernetes. Both are acting as a orchestration system for your containers, right? Correct? Podman is equal to a container engine, Janvi, right? The Podman which you have, that is acting as a Docker. That is not an orchestration, correct? Now, can we customize Kubernetes and also write our own custom controller as per we need deployment service? If you want the use case or of this container, you cannot change the functionality of the kube controller or the Kubernetes controller. You cannot change the functionality, but you can define the task that, okay, what you want to do with the deployment service. Ultimately, the goal is to do some job. But if you are thinking that you can change the image or change the environment or the code of the Kubernetes, let's say your controller, then you have to work at a developer level where you can add several functionality to the existing Kubernetes code. But obviously, being a developer, everything is possible. So if you have a capability to edit that code, edit that files in the Kubernetes controller, then you can definitely do that and create a new release and use that new release for your purpose, right? So being a developer, everything is possible, correct? Fair enough. So we were talking about Docker Swarm, right? So if we talk about, I think if we take the data from 2018 or further, so if we, because I see that around 2018, the utilization of this Docker Swarm was very much reduced, right? And this Kubernetes was very much popular, right? Around means I don't have the entire data, but there is one site which is there. Let's see, which should give us the data.
Sir, I think I saw a post in LinkedIn which compared Docker Swarm with Kubernetes, saying Kubernetes was better than Docker.
Sorry?
Can you hear me, sir? Yeah.
Yeah, I can hear you. But
Yeah. In LinkedIn, I saw a post where they compared Docker Swarm with Kubernetes, ultimately saying Kubernetes was far better than Docker Swarm.
yeah, I know that, but I'm just trying to get the real-time statistics from Google Trends. Google Trends is the site which shows the statistics for a period of time, which service was most used. Okay, so that is why this trends.google.com is used, right? So here you can find out trends for any specific data, which movie is being trending more, which series is being trending more. You can compare series, right? Which are the places to visit. A lot of things you can search in trending, right? Okay, or I'm not able to find that, but as of now, this Docker song was something which is less used as compared to what you are using in Kubernetes, because Kubernetes is much more reliable and efficient as compared to your Docker Swarm. So if we compare in terms of uh, your installation and initialization part, right? This Docker is something which is easy, right? So this is easy to install and initialize, correct? But at the same time, if you are comparing your Kubernetes cluster, they are more of a complex procedure when you're installing Kubernetes. On the cloud, we are getting a managed offering, right? So we don't see the pain. But if you are running the Kubernetes cluster on your on-premise environment, right? There it is challenging, right? It's a complex procedure to install Kubernetes because there are a lot of dependencies which you need to take care of when you are installing the Kubernetes components, right? As compared to the processing speed, because Swarm is something which is lighter, right? So this is most of the time you will see it is faster when you compare to Kubernetes. When compared to Kubernetes, right? And this is slower if you're comparing to your Docker Swarm. But if you compare this in terms of the reliability, this is not reliable, correct? Also, in terms of feature set, this has less features, correct? At the same time, if you are working with your Kubernetes, Kubernetes is much more reliable, right? Plus, it has many more features. In fact, Docker Swarm is getting soon, it will be obsolete, right? No one is using Docker Swarm these days because no one is integrating those Docker Swarm into the environment, right? So the main idea is because on this Kubernetes cluster, we are trying to create a controller part, right? And there are several nodes on which we are running the container. So if you see only from a Kubernetes perspective, right? Don't go inside the control plane, user plane, a lot of things are there, but don't go inside that, right? By default, you will always see that there is a master node, right? Which we usually refer to as system nodes, right? And you have further integration with your other node, which is your slave node, right? This is your slave node. And slave node is also participating or registered to the master node. And whatever instructions are received from the master node, slave nodes are doing those same tasks, right? Slave nodes are performing those tasks which are associated to the master nodes. So all the instructions are sent from the master and they are being executed by the slave nodes, right? There is the system nodes, and this you can consider as your user nodes. These are your user nodes, correct? Because on the master node, you will see a lot of components are there, right? So if I go to the Kubernetes site, if you go to the Kubernetes, so the standard Kubernetes concepts were derived around this, right? The standard Kubernetes concepts were derived around this, right? This is the open source Kubernetes, right? This diagram is coming from open source Kubernetes, but we have to be considerate that everyone is customizing it, various providers are customizing it, right? So all the components which you see over here, these are the master nodes. And similarly, you have user nodes as well, right? The slave nodes, right? So if we draw this as per this diagram, right? Right. So how it would be happening? You have this master node, correct? There's the master node, and these are your slave nodes. So let us write that. This is your this is your not just this. All of them are acting as a all of them are acting as a slave nodes, right? Since it is an open source offering, right? Component wise, you notice this is your control plane. So control, as soon as the control word is there, which means that, okay, this is acting as a control manager, right? You see, cloud control manager. You have etcd, API servers, scheduler is there, control manager is there. So a lot of components which you see, right? So similarly here also in master node, what is there? Because we are running with the help of Docker, so obviously container engine will be there, right? But let's try to visualize this. Let's say this is my controller manager, and this controller manager is controlling everything. Let's say this is my controller manager, right? And on top of this, let's place your etcd. What is etcd? We'll talk about that, right? This is etcd, right? Then you have your API server. You have API server, right? And then you have another offering which is known as scheduler, right? Scheduler is there. And this is all running with the help of your, we use a different pen, with the help of Docker, right? Without the help of Docker container engine, nothing can work, right? Because that is providing you those runtime environments for it to work. So this is your master node, right? And these are your slave nodes. So on master nodes, you have all the components which are there, right? On the slave node, you also need the container engine. You also need the container engine. So let's say you need Docker, correct? You need the Docker. Apart from that, there is one component which is known as kubelet, correct? And the third one which you have is your kubeproxy, correct? Third one is your kubeproxy. Similarly, this will be there in all the files, sorry, all the nodes which are acting as your slaves, and they are all registered to what? They are all registered to your master nodes. So let's say we have connections, we'll make to this. So it will have connections with the same component which are there. So these are your Kubernetes master nodes, and these are Kubernetes slave nodes, correct? So component wise, what is the use case of these components? We'll discuss, right? Don't worry about that. But architecture should be there, that there are some master files, there are some slave nodes, in which master is something which you cannot eliminate, And if you think that, okay, I have a Kubernetes cluster running, I can only, or I want to only use this, then it is not possible, right? Then it is not possible. Make sense? Before we start or before we move further, questions to everyone? Any question, queries from anyone?
No, sir, not from my side.
Anyone who has any question, queries? Dhanush confirmed. What about others? Quickly respond in the chat.
Can you repeat kubelet and kube proxy?
Sorry.
What is kubelet and kube proxy?
All the components we'll talk in detail, right? I'm just talking about the
Uh,
architecture. It is very.
Architecture is fine. Yeah, yeah, that is right. Yeah.
Everyone, please confirm in the chat so that we can move forward.
ETCD, sir.
Everything we will discuss, right, in detail. Don't worry about that. All good with everyone? Okay, fair enough. So we'll start with one component. Let's say this etcd is being asked. Let's start with etcd, or let's bring this component over here. Okay, so let's talk about the etcd. So this etcd is what? So this is a highly available database, right? It's a highly available key value pair database, right? So we have to understand it from a different perspective. I think that would be the right way. Let's leave it, otherwise it will be very confusing. Let's delete this. Otherwise it will not be clear. That was just only for showing the purpose. Let's draw two boxes. So this is your control plane, right? And this is your user plane, right? And let's say we have to take any cloud provider. So since we are working with AWS, so let's say AWS, or the people who may want to use it with Azure, let's say this is AWS or Azure managed, right? Let's not confuse. Let's keep it one only. But similarly, it will be same for all the cloud provider. This will be AWS managed, right? This will be AWS managed. Just give a moment. I'm getting a call. AWS managed user plane. This is the customer managed. This is the customer managed, right? So whenever you see the term node is what? Whenever you hear the terminology as node, right? This node means virtual machines, correct? In AWS, it is EC2. In Azure, it is virtual machines, right? Because in Azure, we call it as virtual machines. If you are using this nodes, this is the place on which you run the containers, right? On the VM, you place the container. So if you have VMs, correct? On this VM, you put your container engine. You put your container engine. And this container engine was giving the capability to create multiple containers, right? So further on top of that, what you can do, you can run your multiple containers. And these containers are what? These containers are referred to as pods, right? And pod is nothing but these are your containers. So these terminology should be clear to everyone, right? Because we will be using this. This terminology should be clear to everyone, right? So container is equal to pods and nodes is equal to VM.